Hello everyone, my name is Snehaaigali, student of Sri Venkateshwar College of Engineering, Bangalore. I am studying in third sem CSE. Today I am up with brute force approach, which is one of the topic from analysis and design of algorithm. In this brute force approach, I'll be specially talking about this bubble sort technique. So first, let us see the introduction to bubble sort technique, what actually bubble sort is. Bubble sort is a simple sorting algorithm that repeatedly steps through the list. It compares the adjacent elements and swap them if they are not in sorted order. That is, if they are in some descending order and we want to sort it in ascending order. It works on the technique of brute force approach. So now, what is brute force approach? Brute force approach is nothing but trying all the possible solutions to find an optimal solution to a problem. Now here we have the working and algorithm for the bubble sort. It says after the first iteration, the largest element will be in the last position. That is, after completing our first iteration, the largest element of our list, that is our array, will be found at the end position of the array. Then after the second iteration, the second largest element will be bubbled up. It continues till the array becomes sorted. The sorting will be completed after n minus 1 iteration. This means here the n refers to number of elements in the array. Now, for example, if we have 10 elements in our array, so after completing 10 minus 1 iteration, that is after completing 9 iterations, our array will be sorted. Now here we have an algorithm for the bubble sort technique. It says for I is equal to 0 till n minus 1. That is, initially I will be set to 0 and the iteration proceeds till n minus 1 position. If it is true, then come to the inner loop. That is, for j is equal to 0 till n minus 2 minus I. If so, then we enter then move ahead and check for the condition if a of j plus 1 is greater than j. That means if a of initial position is greater than the next position, if so, then swap a of j and a of j plus 1. Let us understand it better with an example. So here we have an array of elements which has 78, 60, 49, 68, 90, 21, 40, and 12. These elements are initially in the unsorted array. Now let us sort this to bubble sort. In the first iteration where I is equal to 0, which is lesser than n minus 1, the condition is true, then we enter the inner loop, that is now j is equal to 0. Now we compare a of j is equal to 0 and a of j plus 1, that is a of 0th position is compared with a of j. This is a of 0th position. A of 0th position is compared with a of j plus 1 position. Since 78 is greater than 49, the swapping process takes place. 49 comes to a of j position and 78 goes to a of j plus 1 position. Now j gets incremented, that is j becomes 1 and a of j is compared with a of j plus 1. That is a of 1 is compared with a of 2. Since 78 is greater than 68, again the swapping process takes place. 68 comes to a of j position and 78 goes to a of j plus 1 position. Now j gets incremented, that is j becomes 2 and a of 2 is compared with a of 3. Since 78 is lesser than 90, there will be no change in the array. Now next, again, j gets incremented, that is 90 is compared with 21. Since 90 is less than 20, 90 is greater than 21, the condition is true, so the swapping process takes place. See now 21 has come to a of j position and 90 has moved to a of j plus 1 position. Now next 90 and 40 are compared. Since 40 since 90 is greater than 40, again the swapping process takes place between 90 and 40. That is 40 is moved to a of j position and 90 has moved to a of j plus 1 position. Now since 90 and 12 are compared and 90 is greater than 12, The swapping process takes place and 90 has moved to A of j plus 1 position. One thing what we can observe at the end of first iteration is the largest element among this array has come to the end of the array, as we have mentioned in the as we have seen in the working of the array. Now, since J has reached its maximum position, then the inner loop will be skipped and we come to the outer loop where I will be incremented. Now I becomes 1. That is, previously I was 0 and now I becomes 1. And now initially J will be 0. Then again the first two elements are compared. That is J of A of J and A of J plus 1. That is A of 0 and A of 1 are compared. Now 49 is less than 68. So there is no need for the swapping procedure. And then J gets incremented. Now 68 and 78 are compared. Since 68 is lesser than 78, so again there will be no changes in the array. Now J will be 2, A of J plus 1, that is J will be 3. A of 2 and A of 3 will be compared. Now 78 is greater than 21. Now the swapping process takes place. See, 21 has come to A of second position and 78 has moved to A of third position. Now 78 is compared with 40. Now, since 78 is greater than 40, the swapping process takes place. See, now 40 has come to A of J position and 78 has moved to A of J plus 1 position. Now, when 78 and 12 are compared, 78 is greater than 12. So 12 and 78 get swapped. See, now at the end of the second iteration, what the array we have got is 49, 68, 21, 40, 12, 78, and 90. At the end of the second iteration, what we have seen was 78, which is the second largest element of this array, has moved to the second largest position of the array. Now, at the beginning of the third iteration, where I is equal to 2, now again the initial elements of the array are compared, where j is equal to 0 and j is equal to 1 are compared. Since 49 is lesser than 68, no changes in the array will take place. And then j gets incremented and 68 and 21 are compared. Now, since 68 is greater than 21, 68 and 21 get swapped. That is, 21 moves to A of J position and 68 goes to A of J plus 1 position. Now we increment J and 68 and 40 are compared now. Again, 68 is greater than 40. So 68 gets swapped with 40. See, 40 has come to A of J position and 68 has moved to A of J plus 1 position. Now 68 and 12 are compared. Since again 68 is greater than 12, 68 and 12 get swapped. Now J is incremented again. Now 68 and 78 are compared. Since 68 is lesser than 78, there will be no change. Then 78 and 90 are compared. Since 78 is less than 90, there will be no change. At the end of the third iteration, where J has moved to its maximum position, we can see that the last three elements are sorted and they are at the highest position of the array. Now, since J has reached its maximum position, the inner loop will be skipped and we move to the outer loop, where now I becomes 3. Then now J is equal to 0 and J is equal to 1 are compared. Since 49 is greater than 21, 21 gets swapped to the 0 position and 49 moves to the first position. And then again we increment J. Now J of 1, sorry, A of 1 and A of 2 will be compared. Since A of 1 is greater than A of 2, 49 and 40 get swapped. And then next J will be incremented, 49 and 12 are compared. Since 49 is greater than 12, we again swap the things. 12 comes to A of J position and 49 moves to A of J plus 1 position. Then we compare 49 and 68. Since 49 is lesser than 68, there is no need for the swapping process. The array remains unchanged. And then 68 and 78 are compared. Since it was previously sorted, there will be again no change in the array. and 78 and 90 are compared. Since 78 is lesser than 90, there will be no change in the array. At the end of the fourth iteration, the last four elements of the array are sorted, and these four elements are the largest elements as compared to these first three elements. Now J has reached to its maximum position, that is 6. So we skip the inner loop and we go to the outer loop again, where I is equal to 4 now. So when I is equal to 4, J is equal to 0 and J is equal to 1 are compared. Since 21 is lesser than 40, there will be no change in the array. Now next we compare 40 and 12. Since 40 is lesser than 12, 40 is greater than 12, we swap the things. Now 12 comes to A of 1 position and 40 moves to A of 2 position. Now A of 2 and A of 3 are compared. Since 40 is lesser than 49, there will be no change in the array. Now 49 and 68 are compared. 49 is less than 68, the condition is false, so no change in the array. 68 and 78 are compared. 68 is lesser than 78, so there is no need to change the array. Now in the next iteration, we compare 78 and 90. Since 78 is less than 90, so there will be no changes in the array. Now at the end of the fourth iteration, we have the sorted things from 40 till 90. Now since J has reached to its maximum position, we skip the inner loop. We come to the outer loop where I becomes 5. And now A of J is 0, A of J plus 1 is 1. Now A of 0 and A of 1 are compared. Since 21 is less than 12, we swap the things again. Now 12 has reached to A of 0th position, 21 has reached to A of J plus 1 position. Now we compare A of 1 and A of 2, that is 21 and 40 are compared. See, 21 and 40 are compared. Since 21 is less than 40, there will be no changes in the array. See, 21 remains as it is, 40 is in its own position. Now next we compare 40 and 49. Since again 40 is less than 49, there will be no change in the array. The next 49 and 68 are compared. 49 is less than 68, so no need to swap the things. Next 68 and 78 are compared. Again 68 is lesser than 78, the condition is false, so no need of swapping. Next 78 and 90 are compared. Since again 78 is lesser than 90, so no need to swap the things. At the end of the sixth iteration, we have the sorted array, that is 12, 21, 40, 49, 68, 78 and 90. Since it is the fifth iteration, we at the end of this sixth iteration, we have the what is this sorted elements, that is we had 7 elements in our list, and at the end of the sixth iteration we got the sorted elements. So now we have reached to the conclusion of the bubble sort. Now, since we have seen an example, how does an bubble sort works, what is an algorithm, and the logic of bubble sort. Now, what we can say in the conclusion is bubble sort is, as we have seen, simple and easy to sort algorithm that is suitable for educational sorting small databases. One thing is bubble sort is only suitable for small databases. It feels or it is not much suitable for the large databases. While bubble sort may not be more efficient sorting algorithm for large databases, its stability and in place make it a viable choice for certain applications. Understanding the principles of bubble sort can provide foundation for learning about more advantageous sorting in the future. So well guys, it was all about bubble sort technique from the brute force approach. I hope this might help you guys. Thank you so much for watching.